This WebEx service includes a feature that allows audio and any documents, other materials exchanged or viewed during the session to be recorded. By joining the session, you automatically consent to such recordings. If you do not consent to the recording, then please not join or participate. This WebEx service is intended to supplement the classroom experience. Duplication or redistribution of lecture capture recordings is prohibited without appropriate consent. We got that behind us. Now let's go ahead and take a look at Chapter 5, which is loops. It starts off by talking about if you have the need to write, for instance, from the computer, welcome to Java 100 times, it would be a tedious process given the skills that you've developed up till now. You'd have to do system.out.println, welcome to Java 100 times, copy and paste and repeat and do it. This particular chapter is going to introduce loops to you so that essentially to do the same thing, you would do these 4 instructions right here. You initialize count as an integer to 0, and then you introduce a while loop. The while loop opens with a parentheses, and you're going to test, and you're going to continue on in that loop for as long as what's inside the parentheses yields a true evaluation. So inside the parentheses is what's known as a Boolean. It can either be true or false. In this while loop, for instance, here we have while count is less than 100. Well, count is initialized to 0, so clearly right from the beginning it's going to be true, and we will go ahead and execute this statement right here, welcome to Java, and print that out. And then we increment count to be 1. The while loop goes from here to here, so it will go back again, and now count is 1, which is still less than 100. And we continue looping along until eventually count is equal to 100. And in that particular case, then count less than 100 is going to be false, so this loop body will not execute, and we will go to the next sequential instruction after the while loop. So that's essentially how a while loop would accomplish the same thing as writing system.out.println 100 times. We're going to now start getting closer to flowcharts. Flowcharts are going to become our friend. As we work with loops and logic, if, else if statements, nested loops, it gets very, very confusing. And in order for you to understand someone else's program or understand how you're going to solve a particular problem, it's always a good idea to use a flowchart. Here is an example of the flowchart that we just described, the while loop flowchart. And to the left, we have the while statement, and inside the parentheses is what gets evaluated to either true or false. This is what's known as the loop continuation condition. And the loop starts here at this curly brace and ends down here at this curly brace. So while the loop continuation condition is true, you execute the body of the loop. The flowchart for this looks like this. You're processing, and all of a sudden you come to a diamond-shaped box, which is a decision block. That is going to yield either a true or a false, which is really the while loop continuation condition. And if the continuation condition is true, you'll note that you do the statement or statements, the loop body, and keep looping until eventually the loop continuation condition is false, at which point you kind of flowchart around the statement or body of statements or the loop body to the next sequential instruction thereafter. For example, we initialize count to be 0, and while count is less than 100, we're going to go ahead and write welcome to Java, and we're going to increment count each time we iterate through the loop. The flowchart would look like this. This rectangle is an assignment statement, or it's an assignment block, or a process block. And in this case, we are assigning 0 into count, and then we are dropping down into the next question, which asks, is the count less than 100? It is 0, so we will come down here and process writing welcome to Java 100 times. Once count equals 100, it will no longer be true that it's less than 100, so we take the false branch and we skip around the loop body and continue on with your program. So those are two flow charts to give you an idea as to how the flow chart would look for a while loop. Tracing the while loop, I'm going to kind of move over because we just did that. And go right to this repeat addition quiz. Quite a while ago, we had a, in listing 3.1, we had an addition quiz.java, which gives a program that prompts the user to enter an answer for a question on addition of two single digits. Using a loop, you can now rewrite that program to let the user enter a new answer until it is correct. So let's look at repeat addition quiz. Here's repeat addition quiz. I'll make it a little bit larger. And the first thing that we're doing is we're generating two integers using the system.current time milliseconds, modulus 10, and then doing it again by dividing by 7, integer division 7, and doing a modulus 10 on that just to kind of give it a little bit of a shuffle. And we will have two numbers generated, integers stored in number 1 and number 2. Next thing we do is we create the scanner. So we're going to create the reference variable input of the type scanner. And now we go ahead and ask the question, what is whatever generated number 1 is concatenated with plus, concatenated with number 2, and follow it with a question mark. And we will get the answer. Let me run this so we can follow it with some example data. Okay, it's asking me what is 8 plus 6. I will say 14. You got it. Let me do it again. And I will do 0 plus 0. I'll say 1. That is the wrong answer. 2, 3. So it'll keep going in this loop until I eventually get the right answer of 0. And then I finally got it. So that's how this program works. So we've generated two integers. And let's do it again so we get something 2 and 1. Okay, and I'll say 2. Wrong answer, and then I'll do 3. All right, so we'll use 2 and 1. So number 1 is 2, and number 2 is 1, just to make it confusing. All right, so number 1, so while number 1, which is 2, together added with number 2, which is 1, so that's a total of 3, is not equal to my answer. And in this case, my answer the first time around was 2. So it's not correct. It's going to tell me I got the wrong answer. Try again. And then I will go ahead and get another read from the scanner object and store it into answer. And then if answer the second time around, I put 3 in. And now while number 1 plus number 2, so 2 plus 1 not equal to 3, that's false. So we'll drop out of this loop and say you've got it right. Now I want to go ahead and focus in on something here that's very important. Let me just tighten up this up a little bit. I don't need this create scanner. I think we know what that is. The structure of this loop demonstrates a standard structure in using a while loop. Before you get to the while loop, the way you can design your solutions is to create what's known as a priming read. And in this case, we are using a priming read to get the first answer outside the while loop. So we use the scanner to get input, and we store answer in here. This is outside the while loop. And now you can test inside the parentheses to see if it's true or not. And then in the body of your while loop, at the very end, you go ahead and get another input from the console. So this structure where you have an outside priming read together with a repetitive read inside your while loop is a good structure to use when you're using a while loop. This comes up very frequently and can solve a lot of difficult problems by using this technique. The priming read, then go into your while loop, and at the bottom of your while loop, get your next read and continue looping and reading. All right, so that's your repeat addition quiz. Okay, write a program that generates an integer between 0 and 100 inclusive. The program prompts the user to enter a number continuously until the number matches the randomly generated number. For each user input, the program tells the user whether the input is too low or too high. So the user can choose the next input intelligently. We'll go through guess number one time quickly. Okay, what we're doing now is we're using a different way in which to generate a random number. We're using the random method from the math class. Between 0 and 100, we're casting it to an integer and we're storing it in a number. Let's generate it. Okay, we now know that the number has been generated and it's asking us, guess the magic number between 0 and 100. Using our binary search technique, we're going to go ahead and split the difference. So 100 plus 0 divided by 2 is 50. So I will go ahead and enter a 50. This will optimize the amount of guesses. My guess is too high, so I need to go ahead and take the new max, which is 50, and the min, which is 0, add them together. I'll get 50 divided by 2, and I'm not in a loop. So that's not that much fun of a game. I only get one shot, so my guess was too high. And if you look at this code, you will see that if everybody could put themselves on mute, because I'm getting a bit of an echo, and I don't know whether or not it's my connection or just hearing myself back again. So if you could put yourself on mute, that would that hopefully will stop the echo. Okay, so what do we have here? We just have an if and else if. If the guess is equal to the number, yes, you got it right. Else, if the guess is greater, then say too high. Else, it's going to be too low. So that's rather straightforward logic using an if, else if, and an else. Now let's look at the same challenge using a loop. This is going to be just guess number. Okay, that's the extent of the program. Make it a little bit larger so you can see it. And in this case, it's basically the same kind of logic, except we're introducing a while loop here. And the while loop will continue on with this same logic, except you will be able to go ahead and narrow your search. So let's take a look by first playing the game. And it says guess the magic number between 0 and 100. I'll use my binary search approach and do 50. 100 plus 0 minus or divided by 2 is 50. My guess is too high, so here we go again. 50 plus 0 is 50. Divided by 2 is 25. My guess is too high, so now I've got 0 and 25. Divided by 2, integer division is 12. So my guess is still too high. So I've got 12 and 0, so the middle is 6. It's too low. So now I know it's between 7 and 12. So 7 plus 12 is 19 divided by 2 is 9. And yes, that's my number. So hopefully you followed my logic in adding the max and the min and then dividing by 2. And this will minimize the amount of guesses that I need to solve this particular problem or game. Looking at the code, we're going to generate the magic number here. We're going to create the input scanner, and we're going to ask the question. And in this case, while guess right here, it's initialized to -1. Here's another technique in which you can use a while loop, where you initialize a variable to a number. In this case, it's an integer, so it's valid, it's legitimate, because guess is declared as an integer. So guess is equal to -1, and then this is going to force us into this while loop. So -1 is not equal to number. It can't be equal to -1 because this random method from the math class will generate 0 to 100. So we're going to always, the first time, execute this loop body. And in here, we're now prompting for a guess. So this deviates a little bit from the priming read and then the read at the bottom of the loop. This is another technique or another way in which you can do things. I personally like the priming read myself, but here's another technique. All right, so we're going to now get a guess. In this case, what did I guess? I guessed 50, right? So if guess is equal to the number, yes, you print the number is whatever it is, if I happen to get 50 right off the bat. Else, if it's too high, put too high. Else, if it's too low, and I continue looping right here. And while guess is not equal to number, okay, I'm going to continue looping through, and eventually I will get the magic number. So here's a while loop, a demonstration of a while loop for this problem. Okay, now a math subtraction quiz loop. It generates one question for each run. We did something similar to this earlier in the semester. You can use a loop to generate questions repeatedly. This example gives a program that generates 5 questions and reports the number of correct answers after the student answers all 5 questions. Executing the subtraction quiz loop. All right, let's run this program so we see how this runs. What is 2 minus 1? 1. Whoops, I put it in the wrong spot. Let me back that out and put it right here. Okay, you are correct. What is 9 minus 9? 0. What is 6 minus 3? Let's say I put 2. It corrects me. It says I'm wrong, and it gives me the correct answer. What is 0 minus 0? 0. You are correct. 7 minus 2 is 5. So it asked me 5 questions. And it says your correct count is 4. I got 4 out of 5 correct. And it also kept track of my test time. While answering those 5 questions, it took me 28 seconds to do this test. At the very end, it also puts out kind of a summary of the questions and what I got correct and what I got wrong. Let's look at this code here now. It's not too long. And one thing I can see is that it has an awful lot of comments, which is very good. As a matter of fact, these comments are the algorithm steps. They're steps that are taken to solve this problem, the subtraction quiz loop problem. First thing that I do is I declare a constant called number of questions. It's equal to 5. We know it's a constant because it has the final keyword, which means that this number of questions cannot be changed. You cannot assign a number of questions to anything. It is declared as a constant. It's going to be 5 for the duration of this program. And now we have some other variables that are getting declared and initialized. We got correct count set to 0, count set to 0, and here we have the start time is going to be equal to the current time in milliseconds. At this particular point that this statement gets executed, the start time gets captured. We are also declaring a string variable called output initialized to the null string. A double quote followed by a double quote is the null string, and it is an empty string. Now we use our scanner to get input, and while count, what is count? Count is 0. Well, count is less than the number of questions. Okay, so it's definitely the first time. We're going to now, 1, get 2 random single-digit integers. And we'd use the math.random method to get integers between 0 and 9 and put them into 1 and 2. Using my example, the first one was 2 and 1. All right, so here we go again with number 1 is 2 and number 2 is 1. Okay, so we're going to have to flip-flop this because the two numbers, well, no, we're not. We're going to, because it already was flip-flopped. But what this code is doing is it's saying if number 2 is less than number 1, we want to go ahead and flip-flop those numbers because this is subtraction, and we have to have a larger number subtracting a smaller number. If number 1 was equal to 1 and number 2 was equal to 2, then we would need to go ahead and create a temporary area in storage to store number 1, and then take number 2 and put it into number 1, and then take what was stored in temp and put it into number 2. That in essence flip-flops the two numbers so that the larger number is stored in the variable number 1. The next step, step 3 in the process, is to prompt the student to answer what is number 1 minus number 2. All right, we ask the question, what is 2 minus 1? And we get the answer from the console and store it into answer. The fourth step in the algorithm is to grade the answer and display the results. Well, if, now in parentheses, this is going to be a Boolean. Whatever's inside the parentheses is going to be evaluate or yield to true or false. And don't forget to use the double equals. That's the equivalency operator. That's going to be yielding a true or a false. Remember, if we use one equal sign, it's going to be an assignment operator. And it will be allowed to be used here, but you're not going to get the right results. So be cognizant and very careful to make sure that you are using the equivalency, the double equals, whenever you have an if clause, such as this. So number 1, 2 minus 1, equivalent to answer. I put 1, the answer is correct. So this whole thing evaluates to true, and I will execute this loop body, or actually it's not a loop body, the if block. And I will put you are correct, and I will go ahead and increment my correct counter by 1. Else we don't do that. And then down here, we increment the overall counter. So I've got 1 correct, and I've had 1 question asked so far. This is an interesting little statement down here. This is output plus equals, and then this big long string of concatenations. And what this output plus equals is, it basically is building output and summarizing every question and answer with all of these concatenations and storing it in output. And here's the end of my while loop right here. So output is continually getting built. it starts off with the null. Where's output? Right here, the null string. And now output is going to have a new line and going to put number 1, which is 2 minus 1 equals 1. And then that's my answer. And it's going to do the evaluation. Number 1 minus 2 is equivalent to the answer. And if it's correct, it's going to say correct. Otherwise, it'll say it's wrong. And you'll see right down here that it builds the first line for the first question. 2 minus 1 equals 1 is correct. And now we'll go back up and loop again and generate 2 more random integers, 0 through 9. It'll continue on with this process. And then once we're done with 5 questions, we drop out of the while loop. And then we take a snapshot in time using the system.current time in milliseconds to capture the end of my quiz, store it in a variable of type long called end time, and then I'll calculate the test time to be equal to the end time minus the start time. And then I finally print out the correct count is whatever my correct count accumulated to be up here, concatenated with a new line that says test time is equal to whatever my test time is divided by 1,000, because those are milliseconds after all. So I need to convert it over into seconds and then report it as seconds. And then at the very end, I put a new line out, and then I put my big, long accumulated output string. And that accumulated output string is from the 5 iterations in the loop, and it is output eventually will be this section here in blue. Okay, so that is the subtraction quiz loop. Okay, Sentinel value. A sentinel is a guard at a castle. It is something that allows or denies entry into a protected entity, such as a castle. So a sentinel value in loops is to use a particular value to determine whether or not you should continue looping or not. Oftentimes, the number of times a loop is executed is not predetermined. You don't know exactly how many times you're going to loop. You may use an input value to signify the end of the loop, such a value is known as a sentinel value. And let's go through an example. Okay, a nice small program. Make it a little bit larger. All right, we're getting scanner input. We're asking the question, enter an int value, and the program exits if the input is 0. We'll run this here so we can see how it works. Enter an int value. I'll put 1, 2, I'm looping 3, and then I'll hit 0. And I get out of the loop because I entered 0, and it gives me the sum of all of my integers entered as 6. This would be a good example for a cash register application, where you are processing items on your cashier's belt, and eventually you're going to come up to the last item, and you need to total it. Well, you can enter 0 because there really isn't anything that's sold in your store that's $0 or 0 cents. So you can use 0 as a very good sentinel value to exit out of the loop. So here we are asking for integers, and we store them into a variable called data. We're going to initialize sum to be equal to 0. And now while data is not equal to 0, so this is a priming read out here, And while data is not equal to 0, the first time in, I put 1. So while 1 is not equal to 0, I'm going to go ahead and take 1 and accumulate it into the accumulator variable called sum. So sum now has 1. And now I have, toward the bottom of my while loop, I have my loop read. And in there, I'm going to go ahead and ask the question, enter another one, exactly the same as up above, and I will go ahead and get my next entry from the console and store it into data at the bottom of my while loop. And I entered 2, so while 2 is not equal to 0, I will continue to accumulate sum. Eventually, I'll put 3 in, and then I'll eventually put 0. And while data, 0 is not equal to 0, that's false. So we get out of the while loop, and we drop to the next sequential instruction after the while loop, and we put system.out.println, the sum is whatever the accumulated amount is in the variable sum. Again, this is a very good example of using a while loop with a priming read and a Sentinel value. This slide basically just says, do not use floating point numbers for loop control variables. We have a while loop where we're looking at item not equal to 0, and we're declaring item as a double. That's not a good idea because, as you know, floating point numbers are approximations. Whether it's a float or a double, it's an approximation. So as you increment or decrement your loop control variable, it's approximations, and it may never equal 0. It may be very, very close to 0, but it may never equal 0. So this is a strong recommendation. Do not use floating point values to check your loops. All right, so that's the while loop. The next type of loop is the do while loop. And there's not really much to this. It's pretty much the same. The statement of body, the statements or the loop body occurs first, and then you ask the question whether or not you want to continue with this loop. If you do, you keep executing until you no longer want to continue on with this loop and you drop through. The structure looks like this. You start with a do statement, open curly brace, and then you have your loop body, all the statements that you want to do, and then at the bottom of your do while loop is where you tag on the while keyword, and inside the parentheses is going to be a Boolean, your loop continuation condition. It will be either true or false, and that will determine whether or not you continue looping or not. Don't forget the semicolon here. You need to put a semicolon. This is the end of a big do while statement. The third type, the last type we'll discuss, is the for loop. And the for loop has the following structure. Let's make it larger. The for loop has an initial, I'll lose that. I gotta go back. This right here is the first part inside the parentheses of a for loop. The first part is the initial action. In most cases, you're initializing a variable, your loop control variable. Let's say I equals 0. I, J, K, you can use any letter. Those are conventionally used for loop control variables, and they are of the type int, normally. So a good example would be for I equals 0. That's your initial action. It's followed by a semicolon, and then the next section is your loop continuation condition. Well, you're going to continue looping for as long as this condition is true. And then your third and final section inside the parentheses is the action after each iteration. What are you going to do? Most cases, you wind up incrementing the loop control variable, I++, such as what's going on over here. The for loop will go ahead and usually has a curly brace. If you only have one statement in your for loop, you don't need the curly brace, but more often than not, you need curly braces because you have more than one statement in your loop body. And then the for loop body ends at the closing curly brace. Here's the flow chart. And here is an example where we initialize I, we declare I as an int variable, and now we're setting I equal to 0. That's your initial action. And then this is your loop continuation condition right here, while I is less than 100. And at the end of our loop, we're going to go ahead and increment I by 1. And here we print out, welcome to Java. It will loop 100 times. Here's the flow chart. And we can skip through the trace. I'm sure you can follow this. This only does it twice. And then you fall through. What this is bringing up is that this initial action in a for loop can be a list of 0 or more comma-separated expressions. The action after each iteration in a for loop can be a list of 0 or more comma-separated statements. Therefore, the following 2 for loops are correct. They are rarely used in practice, however. Not a big fan of this one right here, okay? I would strongly suggest you don't write any kind of loop like that. But this I have seen in my travels where you have a loop control variable. I'm sorry, your initial action is to set I equal to 0 and set j equal to 0. And you're going to continue looping for as long as I plus j is less than 10. And you are going to increment I and increment j at the bottom of your loop every time. Sometimes you'll see you'll increment I and decrement j. And you'll get some rather complicated loops, but this is essentially like looping within a loop. But you'll see this, and it does occur. I wouldn't suggest, and I've never really run into something that looks like that, so don't do that. It's saying here that the loop continuation condition of for loop, if it's omitted, it's implicitly true. I've never seen it. I've never seen anything that looks like this. I do see here frequently where they would use a while loop and using the keyword true, and then opening up the loop body to do some statements. And this is a while loop that will continue on indefinitely because true will always be true, and it will therefore always execute this loop body. So you better make sure you have a way in which you can get out of this loop. Some forewarnings here. Be sure to not put a semicolon after your parentheses in your for loop. Essentially what that does is it just basically ends the for loop. And then you're just going to have one statement, you're going to print it out, and you're going to continue on. So this is not a compile error, this is a logic error. So you could inadvertently wind up putting a semicolon at the end of your for declaration, and this is no longer a loop, this is nothing more than just a statement. So be careful about your semicolons. Here's another one with a while loop. If you put a semicolon after the expression in parentheses, this is a logic error. It's not going to get caught by the compiler. And you'll process just once. You will not loop. And you will always process this system.out statement. Increment I, and then go to the next sequential instruction. This, however, is correct. In a do-while loop, you do need the semicolon. The others, you do not. It will allow you, but it is a logic error. Which loop to use? Well, the recommendations basically say, use the one that's most intuitive and comfortable for you. In general, a for loop may be used if the number of repetitions is known, as for example, when you need to print the message 100 times. A while loop may be used if the number of repetitions is not known, and you might want to use a Sentinel value, as the case of reading numbers up until the input is 0. And a do-while loop can be used to replace a while loop if the loop body has to be executed once before testing the continuation condition. Next, we get into nested loops. Write a program that uses nested for loops to print a multiplication table. Here is a program that will go ahead and print a multiplication table. Running this. This has your multiplication table, your 1 through 9 multiplication table, all nicely spaced out and formatted in good fashion. Let's look at this code. First thing that we're doing is we are printing out the header, multiplication table with some preceding blanks so it can be indented and spaced out and balanced. Next, we print out a handful of blanks, which gets us to like right in front of this 1 right here. Now we've got a for loop, and we're initializing j to be 1. It's of the type int, and we're going to continue on while j is less than or equal to 9, and then we're going to increment j. There is no curly brace here, so this for loop only includes one statement, and we're doing system.out.print a bunch of blanks and a j. So we'll start with 1, and we're going to print this 1, and then we're going to go ahead and loop, and we're going to increment j. Now j is going to be 2, and we'll put some preceding blanks and then print a 2, and we'll loop all the way to the 9 in this for loop. Next statement is to go ahead and put a separator line. We'll go to a new line and put some dashes, and that will separate the header or the column headings. And now we have another for loop. And this for loop has more than one statement. We are declaring and initializing I equal to 1, and I will continue on for as long as I is less than or equal to 9. So it'll go from 1 to 9, and after each iteration in the loop, it will get incremented by 1. So I will become 1, and then it'll go 2 all the way up to 9. And here we are printing I, whatever, so the first one is going to be 1 concatenated with a vertical bar. And here's your 1 concatenated with a vertical bar. And now we have yet another for loop. So this is a nested for loop inside another outer for loop. And this particular for loop, we're using j, we're initializing it to be 1. We're going to go for j to be all the way up to 9, and we're going to increment j by 1 each time. And we are using the printf method here to print out the results of I times j. So in the first case, it's going to be 1 times 1, then it'll be 1 times 2, 1 times 3, 1 times 4. And this printf method says to go ahead and put out for at least 4 characters the decimal integer. So this should be separated by 4 characters all the way across. So here is your for loop that goes all the way across. It'll eventually print out the first row. And then we're going to go ahead and do a system.out.print line, which would go ahead and bring us down to the next. And we're going to now increment I to be equal to 2. And we put 2 with the vertical bar. And then we do the same calculation, and you can see how this whole thing works. So it's not a lot of code, but it is complicated, especially when you start getting into nested loops. This is where flowcharting comes in very handy. If you write this as Java code, at first glance it's kind of rough to see what this code is doing, but if you went and tried to write this on a piece of paper using flowcharting diagrams and symbols, I think it would be a lot more obvious as to what it's doing. Okay, so that's your multiplication table. This is repetitive. This is just using the test sum, again using floating point numbers. They are approximations, so you may not get the test to be equal. All right, finding the greatest common divisor. We know what a greatest common divisor is. If you have 2 numbers, it's the largest divisor that evenly goes into both numbers. It says write a program that prompts the user to enter two positive integers and find the greatest common divisor. And the solution is suppose you enter two integers, 4 and 2. Well, the greatest common divisor is 2. Suppose you enter two integers, 16 and 24. Their greatest common divisor is 8. So how do you find the greatest common divisor? Let the two input integers be n1 and n2, so you know number 1 is a common divisor, because 1 goes into every integer. But it may not be the greatest common divisor. So you can check whether k, and for k, which goes from 2 to 3 to 4, so this k is just going to be incrementing, and so on, is a common divisor for n1 and 2 until k is greater than n1 or n2. In other words, it will continue on. You'll keep incrementing k until it becomes greater than the smaller of the two numbers. Let's look at greatest common divisor. I'm going to run it so we can see what our output looks like. Enter our first integer. I'll do 12 and 6. The greatest common divisor for 12 and 6 is 6. I'll do the first integer. I'll do 9 and 6. The greatest common divisor for 9 and 6 is 3. All right, we'll use this as our test data that we can go through. So we're going to get scanner input, and we're going to put what I entered was 9. That's going to be going into N1, and I'm going to go ahead and put 6 into N2. All right, we're going to set the GCD equal to 1, because we do know 1 goes into every number, so it's going to go into 1. It's going to go into 9. It's going to go into 6. So we'll start off setting GCD equal to 1. Now we're going to initialize k to be equal to 2. That'll be our counter. And while k is less than or equal to n1, n1 is 9, so 2 is less than 9, and 2 is less than 6. And that's true for both occurrences. So I have a true ANDed with a true. That's an overall true. I will go ahead and execute this loop body. In here, I've got an if clause that says if n1, which is 9, modulus k, k is 2. So that's not equivalent to 0. We have a remainder. And it's followed by an and. So I've got a false ANDed with a anything is going to be a false. So this statement will not get executed. And we will not put 2 into the GCD for 9 and 6. Now we bump k. Now k becomes 3. And while 3 is less than 9 and 3 is less than 6, it is, we're going to ask if 9 modulus 3 is equivalent to 0. That's true. There is no remainder. ANDed with 6 modulus 3 equivalent to 0. And that is true. I have got a true ANDed with a true. That's an overall true. So I will go ahead and execute the loop body, which is just one statement, and I will assign k, which is 3, into the GCD. And I will continue to bump k to be now 4. And it will continue on up until it hits 6. And when k is 6, when 6 is less than n1, that's 9, that is true. And k is less than or equal to, when 6 is less than or equal to 6, we're going to continue on with that. But once it gets past this, this is now 7, and it will be a false condition. So 7 will be greater than 6. And we no longer test to see if 7 or above is a greatest common divisor. It makes no sense because it's larger than the smallest number. And then we dropped out of our while loop, and we will go ahead and print the greatest common divisor for 9 and 6 is whatever I had stored, and the GCD greatest common divisor is 3. Okay, so that's using a rather short while loop, and let's see what's next. Okay, future tuition I'm going to skip over because that's nothing new to that. I'm going to go to the next one here. You can take a look at that. It's posted in Blackboard. Decimal to hex. Here's one that you should take a closer look at. Close all projects, and let's open up decimal to hex. All right, I'm going to go ahead and run this, and we're going to enter a decimal number. I'll put in, I don't know, 18. 18, the hex number is 1, 2. Okay, it's not a decimal 12, it's a hexadecimal 1, 2, which means it's one group of 16s and two groups of 1, which is a total value of 18. If I put in 255, which is the largest value you can put into a byte of storage, the hex number for 255 in base 10, well, the hexadecimal value is FF, which is 15 groups of 16 plus 15 groups of 1. Add that all up, it comes to 255. I'll run it one more time, and I'll put in 123, and the hex number for value 123 is 7B as in Baker. Let's see how this program is converting decimal numbers into hex. We're using scanner input. We put in the decimal number. I put in 123. 123 gets stored into the variable called decimal. I am initializing a hex string called hex. And now I'm quickly going into a while loop. And while decimal 123 is not equal to 0, that's true, so I'm going to execute this loop body. And I'm going to take decimal modulus 16, and I am going to, that's the remainder function, and store it into hex value. Let me go ahead and pull up my calculator. Where's my calculator? There it is. Okay, let's see if we can make this a little bit smaller. Put it over here. And now I am taking 123 modulus 16. Over here, I can change this view to be a programmer's calculator, and it changes this. This is Windows 10. It's a little different interface, but if you have a previous version of Windows, all these functions, although they look different in your calculator, they're all still here. So I'm going to take decimal, which is 123 modulus 16. I'm going to do 123 and modulus 16. And that's going to be equal to 11. Okay, so now 11 gets stored into hex value. I rewrote this code here because it's a little complicated using this technique here with the question mark and everything. I rewrote it to be a little bit more straightforward. So hex value's got 11 in it. If 11 is less than or equal to 9, it is, that's true. ANDed with a hex value 11 greater than or equal to 0, it's true. 11 is greater than or equal to 0. So I've got a true ANDed with a true. That's an overall true. Well, then what I'm going to do is take the hex value, which is 11, and I'm going to add the character 0 to it. We need to go ahead and get this into a character hex digit. So we're going to add the ASCII value of character 0. The character value of 0 is a hex 30. And I'm going to add 11 to that. Okay, so character 0 plus 11 is going to bring me up to a hex 3B, I guess it is. And this 3B is going to now get cast to a character, and this 3B is going to be equal to B. This hex digit is B. And now that's where you have the B, the 11, stored in hex digit. We don't do the else statement right here. And the next thing that we do is we take hex digit plus hex. Hex was initialized to null, so we're going to take the hex digit B and store it into hex. So now hex has the value, the character B in it. And we get to the bottom of our loop. We come back up here, and let's see. So we have, while decimal, which is 123, is not equal to 0. Here's a good example of where you should have a piece of paper and a pencil and writing down all your variable names and then keeping track of what they get changed to on paper with your pencil. Because all these variables are going to change as we loop, and you need to make sure you keep track of them. So what do we have here? I'm doing it in my head, and I believe we still have 123 as decimal. So we're going to, oh, we didn't do this right here. Sorry. We have to do this statement here. And so we're going to store decimal integer division by 16 and store it into decimal. Well, 123 integer 16, let's clear this. And we'll do 123 divided by, now this is integer division, we're dividing it by 16, and that's going to be equal to 7. So now decimal contains 7. And we go back up to the top of our while loop. While 7 is not equal to 0, that is true. We're going to take decimal, which is 7, modulus 16, and we're going to get what? We're going to do 7 modulus, where's modulus? Modulus 16, and that's going to be equal to 7. It's the remainder. We have a 0 quotient with a remainder of 7. And we're going to store that into hex value. So now 7 is stored into hex value. We have hex digit as a char data type. And now while 7 is less than or equal to 9, that's true, and 7 is greater than or equal to 0, that's true, we'll execute this statement and say the hex value, which is 7, and we're going to add a character 0 to it. And this will be, and the hex value is now going to be 37. That now gets cast to a character and stored into a hex digit, and that's going to be the character 7. So a hex digit will now contain the character 7. We don't do the else, and then we take the hex digit 7 and concatenate that to what was in hex, which was B. So this now gets evaluated to 7B. This gets stored into hex. So now hex has 7B. And now we're going to do integer division, decimal divided by 16. Now we have the quotient, which is 0. And we're going to come back up here. And while decimal, which is now 0, is not equal to 0, that's false. So we get out of the while loop, and we now come and print out the hex number is hex, which is 7B. So that's a very small while loop with what's inside it is an if and an else, but it's rather tricky. And this is where you need to have pencil and paper and trace all of your variables as they change throughout the loop. That's how it converts a decimal number over into a hexadecimal. Monte Carlo, I'm going to skip over. That's another way to approximate pi. And I do want to go and show you a test break and a test continue program that test the break and continue keywords. Okay, test break. We have a variable called sum equal to 0, number initialized to 0, and while 0 is less than 20, we are going to increment number. So 0 will then become 1, and then we're going to add the number into the accumulator called sum. So sum after the first iteration is going to have 1 in it, and if sum is greater than or equal to 100, we issue a break statement. Well, sum is 1 the first time around, and now we're going to go ahead and while 1 is less than 20, it is, so we're going to make it 2, and we're going to add sum plus equals number is the same as saying sum equals sum plus number, so we're going to now add 1 and 2 together and store it in sum, and you're going to put 3 into sum. And if sum is greater than 100, we're going to issue the break statement. The break statement will get out of this loop, this while loop. So now sum has 3 in it. And as you can see, this will continue on until eventually number is equal to 20. And at the very end, we're going to print out the number is whatever the number is that it was accumulated to. And the sum is going to be reported as well. Running this program, you'll see that the number is 14 and the sum is 105. What is this program doing? This is adding up the integers from 1 to 20 and stopping once the sum is 105. And once you've stopped, you report what the sum is, 105, and also when the sum is over 100, and so the sum happened to be 105, and the integer that got us over 100 is 14. So 14 plus 13 plus 12 plus 11, 10, 9, all the way down to 1 will add up to 105, and that gets us over 100. So this break statement, in effect, allows us to get out of this while loop. Let's look at the continue. All right, the same type of thing. We've got sum equal to 0, number equal to 0, and while number, which is 0, is less than 20, we're going to increment number. Now it's 1, and if 1 is equivalent to 10, that's false. It will, or, so it's an or, not an and, so I'm going to have to still evaluate the second half of the expression. So I've got a false ORed with number equivalent to 11. That's also false. So that is not going to execute the continue instruction. It will go ahead and execute this. And in this case, we're going to go ahead and take number, which is 1, and store it into the accumulator. And then we're going to loop back around and increment it to 2 and keep looping. And what this particular expression does is it says when it hits iteration 10 and iteration 11, we are not going to go ahead and add those 2 integers into our accumulator. So if number 1 equals 10, or if number equals 10 or number equals 11, we're going to issue this continue statement. And the continue statement says go to the bottom of the loop. So we go to the bottom of the loop, which essentially is skipping over this one instruction, but it goes to the bottom of the loop and then goes back up to the top and continues executing. This program will go ahead and sum up all the integers from 1 to 20, skipping over 10 and 11. And the technique used is the continue statement. So here are here's our break statement where we break out of the loop and go to the next sequential instruction outside the loop body of the while statement, of the while loop, and the continue statement, which says basically to get to the bottom of the current loop that you're in and skip over any instructions after the continue statement. So those are two tools that you can use to get out of a loop. And here's the program for guessing a number. You can rewrite it using the break statement. We've done this before, so let's just take a quick look at that and test using break. Oh, I didn't queue that one up here. Let me get that. Guess using break. All right, what are we doing first? We're getting two numbers generated randomly between 0 and 100. We're storing it into number. Let's run this so that we can see what we're doing. Guess the magic number between 0 and 100. All right, your guess is, we'll go through the binary search and do 50. Guess is too high, so I'll take 50 plus 0, divide by 2, and I get 25. Guess is too high. I'm going to take 25 plus 0 divided by 2 and get integer division 12. And my guess is too low, so now I got to go 13 plus 25 is 38, divided by 2 is 19. Put that one in, and my guess is too low, so now I'll do 20 to 25. That's 45 divided by 2 is 22. And my guess is too low. I'm not that lucky this time around, so I've got 23 to 25. Add that up, it comes to 48 divided by 2 is 24, I think. And yes, that's my number. Okay, so you saw my approach. You saw what I did. Here's the code. Not too difficult. I'm generating the number. In this case, what number was it? My number was 24. And I use the technique of binary search. And this here is a while loop that is always going to execute. We're using the true keyword, so this will indefinitely loop. So that means that there better be a way out of here. Somehow there ought to be some break statement to get us out of this while loop. And then the rest of the logic should be straightforward and familiar to you. We're getting our guess, and if the guess is equal to the number, boom, we put out, yes, the number is whatever it is, 24, and we break out of the loop, out of the while loop. The while loop is the last thing that's done, so the program will end. But if it is not equal to number, then we execute the else if. If it's greater than, you put out too high, else it's too low. And you keep looping indefinitely until the end user eventually picks the correct number. All right, so that's an example of using the break statement in a while loop and also using the true keyword, creating an indefinite loop that would need to be exited by the break statement. I'm going to skip over the prime number. Everybody knows what a prime number is. It's a number that's divisible by itself and 1 only. And it's a rather interesting program. You can take a look at it. I also included a flowchart here that is pretty small, but if you do the replay, you can probably expand it and take a closer look at it. But this is how you would go ahead and print out, I think it's the first 50 prime numbers 10 to a line. And there's all these loops within loops. It's kind of complicated, but it does produce some nice results. Okay, I think that brings us to the end of Chapter 5. Yep, that's the end of it. Let's see if there are any participants that have any questions. I've got Drake, Julio, and Michael Shiro still hanging in there. Do any of you guys have any questions on what I went over? I know I went over it quickly, but it is being recorded, and you can go back and and stop the recording and play with it in NetBeans and experiment. But do you have any questions at this point?
I just want to ask about the I++. You only use it within the for while loop after, right after the system, what's in the output, right?
Yes, the for loop uses the I++. You can also use J++. You can put them together, but that is conventionally what is used in the for loop. It's not used anywhere else. So you would need to put it in the while loop or the do while loop. The for loop, it's up in the top and inside the parentheses. Okay, good question, Mike. Did I answer it?
Well, yeah, partially, yeah. I mean, what if, well, you don't have to use the I++ on the other ones, which is not in the loop, right?
That's correct. Yes, you don't need to use I++. You can design your loops any which way you want. Oftentimes, there is a loop counter. In some cases, you could do while it's true. So there is no loop counter. Okay?
Okay, thanks.
All right, any other questions? Are we good, Julio? Drake? Okay, well, I guess we can call it a night. Thank you all for participating, and I will post this shortly in Blackboard. Take care and have a good night.